Hello everyone, welcome back to Hobby Plus. Today our discussion matter is LED driver. When we try to drive a LED with our DC power supply, we cannot drive the LED properly. After some time it will be burned out. It is very difficult for drive the LED. How does the LED driver do with the LED panel chip? But in that video I will discuss you how the LED driver is work or how you can make a LED driver for your LED. First of all, when you purchase a LED chip from your market, then you have to know what is the wattage of this LED. Here it is LED panel, I mean LED chip, whatever it is. You have to know what is the input voltage and how much current drive the LED. Here is a circuit where the LED voltage is 12 and LED ampere is suppose 0.7 amps suppose or 0.5 amps. I want to drive it 0.5 or 0.6 or 0.7. In that case, I make a driver. That means this LED get 12 volt and 0.5 or 0.6 or 0.7 ampere current. But we have to control the current by this circuit. If you don't do this, your LED will be burned out. So many people ask me why the DOB or why the LED panel or why the single LED chip not working after little some time. Today I make a circuit here. There is a two transistor, both are a NPN transistor, that means collector, emitter and base, collector, emitter and base, both are same number, that is NPN transistor. Now we want to understand how this circuit will work or how can we design the circuit. Here is a transistor, here is a voltage. When you give this voltage in this circuit, that means to LED it will come to collector of this Q1 and also through resistance it will come here to the base of the Q1 and also collector of this Q2 transistor, right? So in that case this transistor is on because this voltage, I mean base voltage, higher than emitter voltage. So when this voltage appear on the gate, I mean base, and this voltage appear on the collector of this transistor, and here is the resistance 2.2 ohms, that means this emitter very close to ground. So this voltage much more higher than emitter. This transistor is on, let voltage through this transistor go to emitter, then through resistance goes to ground. When this LED get more ampere or draw more ampere, then that means this point, I mean emitter of this Q1 and base are connected to the emitter. Q2 base are connected to the emitter. That means this point is voltage is high. When this voltage is high, that means more than 0.7 volt of this emitter, that means this transistor also in working condition, I mean short or on. When this transistor is on, this voltage, I mean base voltage of the Q1 goes to a collector to emitter, because this base is on, because more 0.7 volt higher than emitter. So the Q1 base voltage goes to low. That means this transistor goes to off. If this transistor goes to off, that means base voltage goes to off. I think you understand that. Q1 base voltage goes to off. When the base voltage goes to off, that means Q2 goes to off and Q1 goes to high or on. So that is the automatic circuit. You can design this circuit for your LED panel or chip, whatever it is. Then you get your LED in working condition moreover. Now how can I decide this resistance? Suppose if 12 volt and 2.2 ohms resistance means the transistor through a voltage from collector to emitter, that means internal drop is 0.2 volt. So 12 volt minus 0.2, that means 11.8 volt through this transistor. That is the difference between emitter and collector. You can get 11.2 volt, 2 volt in here, because 2 volt drop here, 0.2 volt drop here, sorry. So if you divided by 2.2 ohms, that means your current is 5.36 ampere. When LED get 12 volt and this transistor drop is 0.2 volt, that means you get here 11.8 volt. When this point is 11.8 volt, this transistor is on, I mean Q2 is on. That means when the Q2 is on, that means Q1 get base voltage is too much low, so automatically this transistor is off and this transistor is on. When this transistor is off, automatically base voltage of this Q1 is off. That means it is a switching circuit. So your LED never get 6 ampere or 5.34 or 5.6, whatever it is, not get in this circuit. So your LED automatically control the ampere and you get the better result of this circuit. I think this video is helpful. You can do this in your lab. After that you test it. If you get any problem, if you get any trouble, then you must or please comment on my comment box, and I will solve your problem. And you know what to do. Please do this. Thank you for watching.